Let's develop formulas for the derivatives of tangent, cotangent, secant, and cosecant. But let's no longer use the definition of the derivative. Let's make use of some other identities. So if you think of tangent as sin x over cosine x, we can now apply a quotient rule making use of the derivatives of sine and cosine as given. So the quotient rule would be set up as you take the denominator, cosine x, multiplied by the derivative of the numerator, derivative of sine x is cosine x, minus the numerator, sine x, multiplied by derivative of the denominator, derivative of cosine x is negative sine x, all over the denominator squared, cosine x squared. Simplifying the numerator gives us cosine squared, and negative times negative is positive, plus a sine squared, all over a cosine squared. And whenever you see a sine squared x plus cosine squared x, we can replace that with 1. That is a Pythagorean identity. So we have 1 over a cosine squared x. There's a reciprocal identity. 1 over cosine x is secant x. But when the quantity is squared, 1 over cosine squared, it is equal to secant squared. So the derivative with respect to x of tan x is equal to secant squared. Now let's take a look at the derivative of cotangent x, cotangent being the quotient of cosine over sine. We have the quotient rule already set up for us. So take a look, we have an extra negative appearing. So if we have extra negatives in the numerator, let's factor them out, leaving us in the numerator with a positive sine squared x plus a cosine squared x, all over that sine squared x. And we have the Pythagorean identity again, where sine squared x plus cosine squared x equals 1. And we're still over a sine squared x. And we have a reciprocal 1 over sine x equals cosecant. So when we have a negative 1 over sine squared x, we can replace that with a negative cosecant squared x. Hence, the derivative of cotangent x equals negative cosecant squared x. And now let's take a look at secant and cosecant. Those are reciprocal identities, so we can do quotient rule again if you would like, or to try something new, let's see if we can make use of power rule here. If you think of writing cosine x to the negative 1 as its reciprocal, 1 over cosine x. So the power rule would give us, here you bring the power down, negative 1, multiplied by the base, cosine x, to the negative 2. Multiplying by a chain rule, derivative of cosine x equals negative sine x. A negative times a negative is positive. We'll keep the sine x on the numerator. Denominator becomes cosine squared x. And then we need to rewrite this in a nice form. I'm going to split this as a separation strategy, 1 over cosine x, multiplied by sine x over cosine x. Because in the denominator, cosine x times cosine x gave us the cosine squared x. This helps us see the form right here, where 1 over cosine becomes secant x, and sine x over cosine x becomes tangent x. That type of rewriting that in that form will develop the derivative of secant x in the form of secant x times tangent x. So I recommend we try cosecant x in a similar way, where the derivative with respect to x of 1 over sine x, we can try the power rule by writing sine x to the power of negative 1. I'm going to encourage that you try it, see if you apply the power rule and reshuffle them in a certain form, so that you can try to get this derivative in this form, where the derivative of cosecant x will turn into a negative cosecant x cotangent x. Go ahead and give it a try. I'll post the answer in the comments immediately below the video.